Hello everyone, this is Karuna teaching the course Microprocessors and Microcontrollers. In this video, we are concentrating on minimum mode and maximum mode of 8086 microprocessor. This is the minimum mode configuration of 8086 microprocessor. In case of pin description video, we have discussed about minimum mode pins and maximum mode pins. First, you should go through that pin description of 8086 microprocessor, then continue this topic. Okay, so here min max pin of 8086 available in 8086 microprocessor. 8086 is operated in minimum mode by connecting its min-max pin to logic 1, that means plus 5 volts. In this mode, all the control signals are given out by the microprocessor itself. This minimum mode system consists of a single microprocessor and components are latches, transceivers, clock generator, memory or I/O devices. Okay, so these latches are buffered output D-type flip-flops. These are used for separating the valid address from the multiplexed address data signals and are controlled by the ALE signal generated by the 8086 microprocessor. So these are the transceivers. These are the bidirectional buffers and these are required to separate the valid data from multiplexed address data signals. These are controlled by data enable pin and data transmit receive pin. Here DAN active low signal indicates the valid data is available on the data bus. Data transmit or receive indicates the direction of the data, that is from or to the processor. Clock generator generates the clock from the crystal oscillator. Since this minimum mode system has 20 address lines, here 20 address lines, AD0 to AD15 and A16 to A19 and 16 data lines, the CPU requires 3 octal address latches and 2 octal data buffers for the complete address and data separation. Let us see how it works. The working of minimum mode configuration system can be described in terms of the timing diagram. Timing diagram can be categorized into two parts. Okay, so timing diagram for read cycle and timing diagram for write cycle. Before going to discuss about this timing diagram, first you should know about the bus. A set of conductors used for communicating information between the components in a computer system is called a bus. There are two types of buses. Okay, so one is internal bus and another one is external bus. Internal bus, if a bus connects two minor components within a major component, is called internal bus. External bus, nothing but when a bus connects two major components, it is called an external bus. 8086 microprocessor consists multiplexed address and data lines to reduce the number of pins required for microprocessor. Okay, so before going to interface 8086 with other devices such as memory, I/O ports, these multiplexed buses must be demultiplexed. Okay, so demultiplexing the buses. What are the buses available in this? Address bus, data bus, control bus. Address bus used to carry address bits, data bus carry data bits, control bus. This bus carry control signals to the memory or I/O devices. So these buses must be required to interface memory or I/O devices with microprocessors. So demultiplexing. So these are the latches and the transceivers are used to demultiplex the address bits and data bits. ఇక్కడ చూడండి AD0 to AD15 రెండు కూడా combined గా ఉన్నాయి signals. With the help of latch and transceiver we can separate the address bits and data bits. So these are the pins available in the minimum mode. First let us see the minimum mode. When processor connects to the plus 5 volts with the help of min or max pin, then processor enters into minimum mode. Okay, or we can say uniprocessor. Okay, manam lab lo use chestam kada, adi processor operating in minimum mode. Okay, uniprocessor, we can call it as uniprocessor. Okay, let us see the timing diagrams. When the processor is ready to indicate a bus cycle, it applies a pulse to the ALE. Okay, so these are the signals generated by the clock generator T, which consists T1, T2, T3, waiting state, TW. These are also known as machine cycles. Okay, address latch enable signal. Okay, so before trailing edge of the ALE signal, the bus high enable, memory IO, data enable, data transmit receiver. These are all should be stable. Okay, at the trailing edge of the ALE signal, the 8282s latches the address during T1 cycle. During T2, S3 to S7 are separated from the address lines. A19 to A16 lines are separated. If the processor wants to perform read operation, read bar signal will be activated during T2. Okay, T2 duration it will be activated. Read bar means active low signal. Bar unnante ikkada pulse must be low. Okay, so in this duration, address status lines are demultiplexed, and in same duration, address data lines A0 to A15 are demultiplexing. After the input data are accepted by the processor, the read bar is raised to 1. Okay, at the beginning of T4. ఇది ఈ క్లాక్ సైకిల్స్ సిమ్యులేషన్లోనే మనకి కరెక్ట్గా రావు. ఓకే, సో బిగినింగ్ ఆఫ్ ద T4 read bar signal will be high. Okay, whenever the transmission is detected, the memory or IO devices interface will drop its data signals at that time. Okay, so data signals will be dropped. Okay, so here this bus carry address bits, and in this duration the same bus carries D0 to D15 bits. So this is about read operation kada. So data transmit or receive. Here because of this read operation, data read bar signal undi chudandi ikkada. Okay, so this is active low signal. Ante. Okay, ఇది ఏం లేదు, ఫస్ట్ అడ్రస్ latch enable ఇష్యూ చేస్తుంది ప్రాసెసర్. తర్వాత డ్యూరింగ్ T1 మల్టీప్లెక్స్డ్ లైన్స్ A16 to A19 are demultiplexed. Okay, this status bits will be carried out with the same bus. Likewise, address data lines multiplex signals are there, no, AD0 to AD50. During T1 carries address bits, and during other remaining timings data bits will be carried out. Okay, so because of this read operation, read bar signal will be activated. Okay, that means active low signal. Okay, so data enable, it is used to enable the trans receiver. Okay, data transmit or receiver indicates the data is reading. Read bar kada, so read bar means active low signal. Similarly, in case of write cycle timing diagram for minimum operation, ఇక్కడ మీకు సిగ్నల్స్ కూడా రిప్రజెంట్ చేశాను చూడండి సైడ్. మినిమం హోల్డ్ ఎక్నాలజీ రైట్ మెమరీ ఐఓ బారు డేటా ట్రాన్స్మిట్ ఆర్ రిసీవ్ డేటా ఎనేబుల్ సిగ్నల్ ALE INTA pins. Same pins are acted as these signals in minimum mode operation. So in this write case, only the difference is write bar. These are the demultiplexed signals, address and status signals, address and data signals. These timing diagrams are required when performing the write operation. So write bar nothing but active low signal. Okay, whenever the data is to be written, then this signal will be activated in this duration. Okay, so this is data enable bar active low signal to enable the trans receivers. This is the write signal, nothing but processor sending the data. That means data transmitting. Okay, so that's data transmitting అనేది active high signal. Okay, T కి బార్ లేదు కాబట్టి active high signal. Okay, so this is about read and write timing cycles of minimum mode operation. Next we have signals hold and hold acknowledge. Okay, so hold acknowledge, this signal is coming from the DMA for requesting the bus. మీకు DMA ఆపరేషన్ తెలియకపోతే CAO లెక్చర్స్ లోనే DMA ఆపరేషన్ ఉంటుంది, you can go through that. Okay, DMA is used to transfer huge data without intervention of CPU. ఓకే, ఐఓ డివైజెస్ నుంచి మెమరీకి, మెమరీ నుంచి ఐఓ డివైజెస్కి ట్రాన్స్ఫర్ చేయొచ్చు వితౌట్ ఇన్వాల్వింగ్ సిపియు. ఓకే, అట్ దట్ టైమ్ డిఎంఏ వాంట్స్ టు హ్యాండిల్ ద bus control. That's what DMA asking for bus through these signals, hold signal. Okay, upon receiving hold signal, processor will issue acknowledge signal if the bus is available. Okay, likewise these signals will be used in case of DMA operation. Whenever 8086 connected to ground, see min or max mode pin is connected to ground, then it will operate in maximum mode. In this mode, processor derives the status signals S0, S1, S2. The signals are present in maximum mode operations. You should thorough with the pin description of 8086 microprocessor. In this mode, we can say processor used for multiprocessing. Multiprocessing means it can be used to perform multiple functions at a time with multiple processors. Whenever this min or max mode connected to the ground, then processor enters into maximum mode, or we can say multiprocessing mode. While performing multi functions, it requires more number of buses. That's what, to control all the buses, bus control is required. ఆపరేషన్స్ అంటే ఏంటి? ఇన్పుట్ అవుట్పుట్ డివైజెస్కి మైక్రోప్రాసెసర్కి మధ్యలో డేటాని ట్రాన్స్ఫర్ చేయడం, లేదంటే మెమరీ నుంచి ప్రాసెసర్కి మధ్యలో డేటాని ట్రాన్స్ఫర్ చేయడం. ఓకే, దట్ డేటా ట్రాన్స్ఫర్ మే బి ఇన్ ఆర్ అవుట్. Okay, that's what here mentioned. Memory read means reading the data from memory. Memory writing the data into the memory. Okay, IO read the data from input device. Okay, next IO write the data to the output device. Okay, in this case advanced write commands are also present. Means these advanced write commands are activated one cycle earlier than the normal write commands. ఓకే, కొంచెం ప్రాసెసింగ్ అనేది స్పీడ్ అవుతుంది డ్యూ టు దిస్ అడ్వాన్స్డ్ మెమరీ రైట్ కమాండ్, అడ్వాన్స్డ్ ఐఓ రైట్ కమాండ్. ఓన్లీ రైట్ కమాండ్లోనే ఉంటాయి ఈ అడ్వాన్స్డ్ signals. This chip is called bus control. Processor derives the control signals using this status information. See, S0, S1, S2 pin description లో చూడండి, 3 bit input signals అయితే మనకి 8 combinations వస్తాయి, 2 power 3. Okay, so these are controlled with the help of these status signals. Bus controller is used to derive the control signals. These are the control signals. The bus controller chip has input lines 3, S0, S1, S2. Okay, these input signals 28288 are driven by the CPU. It derives the outputs ALE, here ALE, data enable, here data enable, next data transmit or receiver, data transmit or receive, memory read command, memory write command, advanced memory write command, IO read command, IO write command, advanced IO write command. In case of maximum mode, memory read command, memory write command signals are used as memory read or write signals. These signals are used to accept or send data from or to the buses. For both of these write command signals, the advanced signals are available. Advanced memory write, advanced IO write. They also have the same function, but these are activated one clock cycle earlier than the IO write command, memory write command signals. Let us see timing diagrams. For this, we have a read timing diagram and write timing diagram. Here in this mode, timing diagrams are also divided into two parts, read and write. Okay, read and write S0, S1, S2. So these are the status signals are set just prior to the beginning of the bus cycles. Okay, so during this time T1 cycle, these status signals will be activated. During this T3 cycle, these signals are inactivated. So here address state lines మీకు తెలుసు during T1 these two signals, these signals are demultiplexed. Okay, and same bus carries address status bus carries A16 to A19 in T1 duration, and status signals will be carried out during T3 cycle. Likewise address data మీకు minimum mode లో లాగానే ఇక్కడ కూడా. So during T1 the address data multiplexed bus carries address bits. Next duration, that bus will carry the data bits D0 to D15. Okay, so this is memory read timing. So that's what here we are using memory read command. Read active low signal, that's what is this signal is active low signal. Okay, so here performing read operation, that's what data transmit or receive. Okay, read nothing but receive R bar. Okay, that's what here we are drawing active low signal. Okay, this is about read timing diagram in maximum mode. Coming to the write operation, all signals are same. Okay, address status bus, address data bus, these are the status signals to generate the control signals for memory write, memory read, IO write signals. Okay, so ఇందులో మీకు స్పెషల్ ఏంటి, advanced memory write command, advanced IO write command. These are the normal commands, memory write command, IO write command. Okay, so these two are active low signal, that's what here indicated as a low signal. Okay, so advanced కమాండ్ సిగ్నల్స్ చూడండి ఇక్కడ ఫస్ట్ అడ్వాన్స్డ్ సిగ్నల్స్ ఫస్ట్ యాక్టివ్ లో అవుతున్నాయి, తర్వాత నార్మల్ రైట్ సిగ్నల్ ఆఫ్టర్ 1 clock cycle ఇక్కడ లో అవుతుంది చూడండి. దట్ మీన్స్ వీ కెన్ సే అడ్వాన్స్డ్ రైట్ కమాండ్స్ ఆర్ యాక్టివేటెడ్ 1 clock cycle earlier than IO write command and memory write command signals. మీరు ఎగ్జామ్లో రాసేటప్పుడు ఇది ఎక్స్ట్రాగా అడ్వాన్స్డ్ రైట్ కమాండ్ సిగ్నల్ ఉండాలి, మర్చిపోకండి. ఓకే, ఒక పల్స్కి ముందే ఇది యాక్టివేట్ అయిపోతుంది ఇక్కడ 1 pulse డ్యూరేషన్లో. ఓకే, సో దిస్ ఇస్ అ రైట్ టైమింగ్ డయాగ్రామ్. దట్స్ వాట్ ఇక్కడ మీకు రైట్ అంటే ట్రాన్స్మిటింగ్ కదా, డేటా ట్రాన్స్మిటింగ్ ఫ్రమ్ మైక్రో ప్రాసెసర్ టు ద ఐఓ డివైస్ ఆర్ మెమరీ. ఇక్కడ we are talking about memory, that's what here we are writing memory write command. Writing means transmitting means active high signal, this is high signal. Okay, and also in maximum mode request grant 0, request grant 1 ఉన్నాయి కదా. So these signals are related to DMA operation. Okay, so to perform data transfer operation, DMA requires bus. Okay, so processor needs to release its bus to the DMA. At the time DMA asking processor about the bus. Okay, so DMA sends a request signal to the processor. This request signal will be detected during the edge triggering. We can say this is edge triggering. Okay, so whenever DMA sends request signal, after some time processor release the bus. Okay, that means CPU grants the bus. Okay, and next DMA will get the mastership over the bus. After completion of this operation, now DMA acts as a master, that's what master release the bus to the processor. Okay, likewise DMA requests the bus and processor grants the bus for performing DMA operation. Okay, likewise you have to explain about minimum mode and maximum mode operations of 8086 microprocessor. ప్రాసెసర్. ఎగ్జామ్లో ఈ క్వశ్చన్ అడిగినప్పుడు మీరు ఫస్ట్ మినిమం మోడ్ పిన్స్ ఏంటి, మ్యాక్సిమం మోడ్ పిన్స్ ఏంటో ఎక్స్ప్లెయిన్ చేయండి. అది మీరు పిన్ డిస్క్రిప్షన్ వీడియో చూస్తే అర్థమవుతుంది. ఆఫ్టర్ ఎక్స్ప్లెయినింగ్ దోస్ పిన్ descriptions related to minimum mode, maximum mode, you have to explain about timing diagrams. Okay, because the working of minimum mode configuration and maximum mode configuration can be described in terms of the timing diagrams only. ఓకే, మినిమం మోడ్ మ్యాక్సిమం మోడ్ అడిగినప్పుడు టైమింగ్ డయాగ్రామ్స్ కంపల్సరీగా ఉండాలి. ఏం లేదు టైమింగ్ డయాగ్రామ్స్లో జస్ట్ మల్టీప్లెక్స్డ్ సిగ్నల్స్ని ఏం చేస్తున్నాం, లాచెస్ని ట్రాన్స్రిసీవర్స్ని యూస్ చేసి డీమల్టీప్లెక్స్ చేస్తున్నాం, అంటే సపరేట్ చేస్తున్నాం, కంబైన్గా ఉన్న సిగ్నల్స్ని సపరేట్ చేస్తున్నాం. ఓకే, ఇక్కడ చూడండి, ఒక డ్యూరేషన్లో అడ్రస్ సిగ్నల్స్ని క్యారీ చేస్తుంది బస్సు, ఇక్కడ నెక్స్ట్ డ్యూరేషన్లో డేటా సిగ్నల్స్ని క్యారీ చేస్తుంది. ఓకే, likewise we have to explain read and write operation in terms of timing diagram in case of minimum mode and maximum mode. చాలా ఇంపార్టెంట్ క్వశ్చన్ ఇది. మీకు సిలబస్లో ఇవ్వకపోయినా యూ జస్ట్ రిఫర్, ఇందులో పెద్ద కష్టమేం లేదు. సిగ్నల్స్ని సపరేట్ చేయడమే. రీడ్ అయితే రీడ్, రైట్ అయితే రైట్ సిగ్నల్ని మీరు పెట్టాలి. తర్వాత ట్రాన్స్మిట్ రిసీవర్, రీడ్ అయితే ఆర్ బార్ అంటే యాక్టివ్ లో, రైట్ అయితే యాక్టివ్ హై సిగ్నల్, అంతే, కష్టమేం లేదు. ఇక్కడ క్లాక్ జనరేటర్ జనరేట్స్ ద clock pulses. Okay, so T1, T2, T3, T4, next again T1 will start. Okay, so we can say these are the machine side. Thank you all. We will meet in next topic.